So in this first lecture I'm going to tell you a few words about Python, such as what Python is, what it can do, what fields of technology can Python be used for, where Python stands among the other programming languages, and how Python has become so popular. So Python is definitely not a large, heavy-bodied, non-venomous constrictor snake. It is a powerful high-level programming language intended for general purpose. So a high-level language means a language that enables the development of a program in much simpler way as opposed to low-level programming languages. Python, as many other programming languages, is a high-level programming language. So with Python you'll never have to think about low-level languages. I said earlier that Python is a general-purpose language, and it really is. The language is used in many fields. According to the official Python webpage, these fields are web and internet development, scientific and numeric, education, desktop graphical user interfaces, and software development. And as you see, Python covers probably everything that can be done with a programming language. Python is a simple, readable and efficient language. If you were to create a program, you'd create that program with much less lines of code using Python than using the C language, for example. And on top of that, those few lines of Python code would be more readable than the C code. And all of that makes Python a very enjoyable programming language. And I bet you'll enjoy whenever you'll be given a new problem to solve with Python. Python was conceived in the late 1980s, and Python 2, version 2 was released in 2000, and Python 3 was released in 2008. Python 3 is the latest release currently, and that is the version we are using in this course. Today Python is one of the most popular programming languages, and its popularity is increasing. So how did Python become so popular? Well, I already mentioned readability, so that's one of the reasons why people like and choose to program with Python. But also Google is using Python, and YouTube was written in Python. Also, Python has a great community that is always ready to help. Other reasons for the popularity of Python can be specific for certain communities. For instance, Python has a great support for data analysis, and you can do whatever you like with to your data. So if you're taking this course, it's probable that you have decided to learn Python for handling data. And I'm sure you'll learn a lot and we'll have a lot of fun programming with Python. I believe all you need is time management. So welcome again to this course, and talk to you in the next lecture. In this lecture, I'll show you how to download and install Python. And I'll also show you how to install Python libraries. And if you don't know what Python libraries are, well, a Python library is like an extension that provides extra functionalities that are not installed with the default installation of Python. For instance, you may be interested in doing musical analysis with Python. By the way, musical analysis is not covered in this course. Anyway, if you wanted to do musical analysis using Python, you need to install an external library, because Python cannot have everything. That way it would get quite a heavy installation. So downloading and installing Python and libraries is the idea of this lecture. And the page you're seeing now is the official Python webpage. And here you can download Python, read the Python documentation, talk to the Python community, etc. If you go to the download menu, you'll see many options where you can download Python. You can choose to download Python from here, but I would suggest you to actually download a Python bundle that does not contain Python only, but also contains an editor for Python, which is called Spider. An editor is some sort of interface where you write the Python code. And the bundle I'm talking about is called Anaconda. You can search on Google for that. And this is the official page of the Anaconda package, or bundle if you like. So they offer the package for the previous Python version 2.7, but also for the latest 3.4 version. And I'll grab the latest version, of course. I'm on Windows, so I want Python for Windows. The downloading has started, so this will take some time depending on your internet connection speed. And here I'm back, and here is the downloaded file. I'll go ahead and execute the file now. And before you do the same, I would recommend you to uninstall any existing Python installations that you might have. You might also keep 2 Pythons in your system if you like, but then when you install Python libraries, you might get confused about which of the Pythons you install the library for. So where did you install the library? Did you install it in the Anaconda Python or in the existing Python that you had? So to clear that confusion, you need to know how environment variables work. So you have to change the environment variables in your computer. Therefore, I would recommend you to uninstall your current Python and install this new one. Or you can even choose to keep your existing Python and not install the Anaconda package at all. But then you would need to install the Spider editor or other editors using alternative ways manually. So back to our Anaconda bundle now. Double click and then follow the installation wizard. So this is the path where Python and its libraries will be installed, and just leave these options checked as they are and wait a while until the installation has finished. So the installation went smoothly on my side, and I'll click finish here, and that's it. If it went good on your side as well, you should be able now to access Python through your command line. So this is my command line in Windows, and if I type Python, the Python console will show up. And here is where we can write interactive Python code. Interactive means that you write and execute single lines of code. And this is great for testing code. For instance, let's find out the sum of 5 and 6. You type in the code and hit enter, and you get the result immediately. You can also write scripts of code in an editor and execute the entire script at once, but we will cover that issue later. So this here is the most simple Python console, and you can execute whatever Python code that you want in this console. However, for more efficiency, more advanced editors are recommended, and Spider is one of them. As I mentioned earlier, Spider was installed along Python via the Anaconda bundle, and you can find Spider among your computer programs. Here is mine, and I'm opening it now. I'll tell you more about Spider in another lecture, so for now I'll just mention a few things. So this here is the Python console, which is equivalent to the black symbol console I just showed you earlier. You can execute code here and promptly get the results. The good thing of Spider is that it also has an editor, which is this one here on the left. The editor is where you can write scripts of code and execute them at once. So that's what I wanted to tell you about Spider in this lecture. Now let me show you what else was installed with the Anaconda bundle. To get a list of everything that has been installed, just go to your terminal, your command line, and type conda list. And what you see is the list of features that has been installed with Anaconda. You can see Python among them, and Spider as well. As you see here, we also have other libraries that were installed with Anaconda, and they may serve for different purposes. These libraries are like extensions that you may want to use for performing spatial operations. For example, if you want to perform a musical analysis. Anyway, the musical analysis library is not here by default, so I'll teach you later how to install external libraries that are not included here. But here you have some other libraries. For example, we have NumPy here. NumPy is a library that allows you to perform numerical computations in Python. And to use these libraries in Python, to use the features of these libraries in Python, you have to import the library. For example, I'll go ahead and import the NumPy library now into the IPython console. So you go back to the Python console and write import NumPy. If you didn't get any error here, that means the library has been successfully imported and now you can use its features to make the program of your needs. If you're interested on any particular library that is not installed by default when you install Python, then I can show you the quickest way to install your desired library. Let's say you're interested on musical or audio analysis, and you have heard that a particular library called PCSets does the work. So PCSets is a real library that stands for Pitch Class Sets, and it's used for musical analysis. Now, to install the library, all you need to do is open your terminal and type pip install and the name of the library, which in this case is PCSets. And the library has been successfully installed. That's it. So the trick here is done by the pip library. So pip is yet another Python library that came installed by default with the Anaconda installation. What the library does is that it downloads the PCSets library from its online repositories, and then it installs the library in your computer, and that's it. You can go ahead now and import the PCSets library in Python to see if it's working good. So that's how to get libraries very quickly. And that's also what I wanted to teach you in this section. Hope everything went well on your side. If not, feel free to drop a question in the discussion section. Okay, so in the previous lecture I showed you how to install Python through the Anaconda bundle. Now the benefit of installing Python through Anaconda was that you get Python and the Spider environment with the IPython console in one single executable file. Now if you don't want to install Anaconda, you can install Python through its official site. And to do that, you just go over to python.org to downloads, and there you have some different versions of Python, and I'll choose Windows, and you have version 3.4 here. Okay, and then wait until the file downloads. Okay, then just execute it, and the installation is very easy then. Just run it and go next, and you set the directory where you want to install it, and keep the options as default if you want, and finish at the end. And Python now should be installed in your computer. Now Python was installed with its default interpreter, and you have it among your programs. So just this one here. So this is the interactive shell where you can type code interactively. So you just type in code and you get the output. But you can also access Python through your command line. So you just type Python and you get the Python shell again here. Now to install a library, you just use the pip library. So pip install, let's say PCSets, which is a library for musical analysis. So the installation is very easy, as you see. And now if you want IPython, you can go ahead and install it using pip again. So pip install IPython. That's it. And then you can access the IPython interpreter through the command line. So instead of writing Python, you write IPython. And then you get a shell which has some extra functionalities compared to the default Python shell. So you can either choose the default Python interpreter or the IPython. So that depends on your preferences. But I use IPython myself. Now one last thing I want to show you is, so this far we looked at how to write code interactively. Now I can show you how to write scripts of code. So to do that, you just go to a folder and then create a script and name it with a .py extension at the end. So .py is a Python extension. And then inside you write some code. Let's say print the sum of 5 and 6. And then to run it, you just go over to run and run module, or you can even press F5 on your keyboard. Okay, the script ask you to save it, and then you get the output in the Python interactive console, as you see. So that's what I wanted to show you. You have the editor here and you have the interactive shell here. Again, I use Spider, so I have both the IPython shell and the editor in one single window. Thanks, and see you in the next lecture. Welcome to this new lecture, and I assume you have already taken the previous lecture where I talked about Python in general, and the other lecture as well, where I showed you how to download and install Python and the Spider environment and the IPython console as well. In this lecture, I'll tell you a few things about the Spider environment, as that will be the environment from where I'll be writing and executing the Python code. So the platform we're looking at is Spider, and Spider stands for Scientific Python Development Environment. Don't get scared by the name. Spider is just an environment where you write and run Python code. So Spider provides an editor here on the left and an interactive shell here on the right. The interactive shell is provided by IPython. So IPython is an enhanced shell where you write and run Python code. So IPython is like the basic shell that you can access through your command prompt, but with some added capabilities that we will discover together as we move through the course. You can also access IPython through your command line by just typing IPython, and you get the same console with the same functionalities as the one you have in Spider. But I would suggest you use the IPython through Spider because you have everything inside one single environment. So to write scripts of code, you should use the editor here on the left. And I have another very short lecture where I'll teach you how to run scripts of code. To program interactively, you use the shell on the right. So programming interactively means writing and executing single lines of code. This is done mostly when testing and where you're not intending to save your scripts of code. For instance, let's instruct Python to print out some text for us. So the function that prints out text is print, and the text we want to print is displaying some text. And so we get the text displayed as soon as we hit enter on the keyboard. So that's what I refer to as interactive programming. You can open multiple shells or consoles here if you like, but normally you'll not have to do so. You can choose to show or hide these two panes by going to View Panes and then click the pane you want to show or hide. So if I check the editor will hide, and I have a full view of the IPython shell. You could also modify the way Spider looks by going to Tools and then to Preferences, and here you have quite a lot of displaying options that you can play around with. For example, I may want to remove the header of the IPython console, so I go to IPython and uncheck that option. Now the next time I open Spider, or even if I start a new console now, the header will have disappeared. There are also options that may become useful when you're managing big amounts of code and script files, but you don't have to know about them as far as you're not building big programs. So I think this is enough to know for now. In the next lecture, I'll start writing code right away by explaining the basics of Python. So talk to you in the next lecture. Well, you should already know that variables in programming are simply some sort of containers where we can store everything. As in other programming languages, in Python we can store numbers, text, lists, files, data, and all kinds of objects. It is very easy to create a variable in Python. Just pick a name for the variable and store something on it. I am creating a variable here and assigning it a number. So, potato price equals 3. And yet another value in this other variable, amount equals 2.5. Notice here that we implicitly declare the data type stored in the variable. In many other programming languages, you'd have to write something like int potato price to declare that the variable will be an integer, so int stands for integer, and after that you'd store the value inside your variable. In Python, however, you don't have to write that much. Indeed, if the number you are assigning to your variable is a whole number, Python understands that and makes the variable an integer type. But I'll tell you more about data types in the next lectures. For now, let's check the data type that our variables hold, and we can do that using the type function. So we're gonna print out the type of the data that our variables hold. So to do that, type print and then open brackets, and inside the brackets we'll write what to print out on the screen. So in this case we want to print the variable data type, and the data type is generated by the type function. So type, and then we pass in the value in the type function, which in this case is a potato price variable. So Python tells us that the value of the potato price variable is an integer. And also let's check the other variable as well. Print again, type, and then we enter the other variable. And the value of the other variable is a floating point number, called float for short in Python. And I'll tell you more about data types in the next lectures. And a few more stuff now. You can assign any other values in the existing variables as well, even different data types from what the variable currently holds. So here I'm gonna assign a string to my potato price variable. Strings are like text, but we'll cover that later. So potato price equals free for today. And the variable will have discarded its previous value by keeping the new one. Till now we have been writing code in our IPython console, which is great for practicing and testing. And so writing code in the console is referred to as interactive programming. However, at some point you're gonna have to write programs or even simple functions which you want to store somewhere, and you want to reuse them later. In that case, what we do is write scripts of code, and we have to save these scripts of code in a .py file. So .py is the extension of a Python file, and I'll show you how to write lines of code in such a file, and also how to execute the file so that you get the output that your code produces. And this can be done through Spider. So we use the editor to write our scripts of code. So the editor is like a notepad program where you write text or even code. Now in Spider your editor may be displayed by default. However, if your editor is not displayed by default, you can display it by going to the View menu and enabling the editor pane. I prefer to have the editor on my left hand side of the screen and the IPython console in the right, but you can put it wherever you want by simply dragging it. There's a temporary empty script showing up in my Spider by default, so that you can use that temporary file to quickly start writing a temporary code, some temporary scripts. But I'll ignore it and close it. And I'll create my own empty script by going to File, and then New File. Now the green code that you see is not actually code. These are code comments. Comments are wrapped by triplets of double quotes, so if you write something that is wrapped in double quotes, Python will ignore it, so it will not read it as a code. The purpose of commenting of comments is to provide relevant code information to humans, so Python ignores such lines, and they are simply used to provide information to us humans. Now let's write some real code in our script in the editor. And I'll print a string here. So print, let's say, first line, and press enter. And now we are not executing anything by pressing enter here. So this is different from the console where we executed lines of code when we pressed enter. Here we execute scripts of code. And to execute, we use another technique. So we can write as much code as we want, and then we execute it using the green triangle icon here in the main bar. Or alternatively, you can press F5 from the keyboard to execute the script. But let me write another line of code before executing my script. Let's say print second line. And before executing, you first need to save your script somewhere in your computer files. So to do that, go to File, Save, and choose the directory where you want to save it. Good. The file is automatically saved as a Python file containing the .py extension, which stands for Python. And let's check that out. So here is the script that we just saved. And of course you can open it using other programs as well, and not just Spider. Let me try and open it using Notepad, for example. So here is the code. Well, let's get back to Spider now, because that's our favorite platform. Well, mine at least. Now we are ready to execute the script. So each line of code written in the script is printed out in the console. So that's the purpose of writing scripts. We write a lot of code and then we execute all the lines at once. Let's add the third line here. So print third line, why not? And once you have saved your script somewhere, you can simply hit run, and the run command will both save the changes you made, so you don't have to click save after every change, and it will also execute the script. At some point, you will want to close Spider and continue later on writing or modifying your scripts. And I'll do just that now. I'll close my Spider, and I'll open up that again. And as you see, the configuration of the windows and the view is the same as in my last session. The script is also the most updated one. So Spider remembers the last view configuration and the script you wrote. So that's it. You don't have to navigate through your file system to locate and open the scripts you write manually, because you can manage them through Spider. And I'll see you in the next lecture. Strings and numbers. Let's kick it off by talking about strings. So strings are simply sequences of characters, and they are widely used in programming. You want to download a bunch of files from an FTP site using a Python script? Well, you'd have to use a string to tell Python the link of the FTP site. Would you want to create a table in Python? Again, you would use a string to name your columns or your rows. Strings? Well, of course they can be stored in variables. Just like this. I'm gonna store 3 strings in 3 different variables here. Let's say variable file name equals weather 1901. Variable table equals temperature. Variable year equals 1901. Strings are always enclosed with quotes, as you can see it. In this case, I use double quotes, but single quotes can be used as well. Notice the last variable year. 1901 is maybe a number in our perception, but Python recognizes it as a string. And the reason for that is that you are declaring it in quotes. This means you cannot perform mathematical operations on that quoted number. And Python knows you are declaring the numbers when you write them without quotes. So if you want to declare a number, you go straight away without using quotes. Let's say real year equals 1901. And look at this. And that gives an error because Python is trying to add up a string with a number. Instead, if you try to add up the other variable we just created, you get what you expected. And that's the sum of the number 1901 with 1. Well, you could also add up strings if you want. You can do that using the add operator. For example, let's say file name plus an underscore, which is a string, plus table. And we have a string. Now, when you use the plus sign for strings, we call the process concatenation. Ignore what I said earlier about adding up strings. I lied. Yeah, so we concatenate strings. And here we concatenated 3 strings. The string contained in the variable file name, the underscore string, and the string contained in the table variable. And the result was a single string. Now, strings are just a bunch of characters. There are no subtypes of strings. Numbers, however, can be of different types. 2 of the types to be mentioned here are integers and floats. Integers are like all numbers, but they include negative numbers as well. The number stored in the variable potato price we created earlier is an example of an integer. And a few words about floats. Floats are decimal numbers. The amount here holds a float number. And so does the potato version, a new variable I am just creating. You can of course check it. If you don't believe me, you can check the type of your variable values. Yes. In most of the cases, you will be using floats for your values, but you could also have to use integers for certain data, such as number of people, for example. It doesn't make sense to have 3.1 persons, so you'll have to use an integer. You could also run into a certain scenario where you really have to use an integer. Say you want to multiply a string, and to do that you would use the multiplication operator. Let's say the string by times 2. Bye bye. And yeah, see you in the next lecture. If else is a primitive yet extremely useful programming tool used in almost every programming language. I don't want to say in every programming language because there are hundreds of languages out there, but I can say that if and else are used pretty much the same in all the languages. The difference is in the syntax, and Python has a very special, easy to read syntax in this case. Have a look at this. If year is equal to real year, print out the string equal, else print out not equal. I would say this syntax is very efficient. Easy to read, easy to remember. So what we're doing here is testing whether the value of the variable year is equal to the value of the variable real year. If they are equal, Python will print the string equal, else it will print not equal. In this particular case, the code under the else line is executed, because the string 1901 is not equal to the number 1901. Yes, they seem equal, but they have different types. That's the difference. The key syntax here is the indentation. Indentation is a white space we put before certain statements in Python. The indentation we apply before statement B tells Python that statement B is dependent on statement A. Sort of B belongs to A. So in this case, the print function statement depends on the if conditional statement. In other programming languages, such as Java for instance, you'd have to write something like this. Let's say if, open brackets, year equals real year, then close the brackets, and then open curly brackets again, and call the print function using a dot notation, and then we write the string we want to print out and start writing the else statement afterwards and use curly brackets again and so on. Anyway, let's get back to Python and try adding some more code in our if-else block for a better illustration of the indentation. I'm gonna recall here the if statement we executed earlier, and I'm gonna add two more printing functions, one under if and another under else. Okay, so if our condition is true, every line below if is executed down to the last indented line. If it's false, every line below else is executed down to the last indented line. And let's execute the block now to see what we get. So we get not equal and check those values again. Now, how much you should indent does not matter. 1 space, 10, same thing, but it has to be consistent. If you indented 4 spaces below if, you should indent the same amount under else. A good practice is to indent 4, so please always indent 4 spaces. Let's play one more time with the code. I'll add another statement outside the if-else block this time. So press the upper arrow to call a previously executed block, and press enter to add another line. I'm adding an unindented line here. Okay, and let's see what we get. So, because we didn't intend the last printing function, the function stayed outside of the if-else block, and that means that last printing function was dependent neither on if nor on else. Therefore, it will be always executed regardless of what happens inside the if-else block. So that was some good information on if-else and indentation. If-else is a primitive yet extremely useful programming tool used in almost every programming language. I don't want to say in every programming language because there are hundreds of languages out there, but I can say that if and else are used pretty much the same in all the languages. The difference is in the syntax, and Python has a very special easy to read syntax in this case. Have a look at this. If year is equal to real year, print out the string equal, else print out not equal. I would say this syntax is very efficient. Easy to read, easy to remember. So what we're doing here is testing whether the value of the variable year is equal to the value of the variable real year. If they are equal, Python will print the string equal, else it will print not equal. In this particular case, the code under the else line is executed, because the string 1901 is not equal to the number 1901. Yes, they seem equal, but they have different types. That's the difference. The key syntax here is the indentation. Indentation is a white space we put before certain statements in Python. The indentation we apply before statement B tells Python that statement B is dependent on statement A. Sort of B belongs to A. So in this case, the print function statement depends on the if conditional statement. In other programming languages, such as Java for instance, you'd have to write something like this. Let's say if, open brackets, year equals real year, then close the brackets, and then open curly brackets again, and call the print function using a dot notation, and then we write the string we want to print out, and start writing the else statement afterwards, and use curly brackets again, and so on. Anyway, let's get back to Python and try adding some more code in our if-else block for a better illustration of the indentation. I'm gonna recall here the if statement we executed earlier, and I'm gonna add two more printing functions, one under if and another under else. Okay, so if our condition is true, every line below if is executed down to the last indented line. If it's false, every line below else is executed down to the last indented line. And let's execute the block now to see what we get. So we get not equal and check those values again. Now, how much you should indent does not matter. 1 space, 10, same thing, but it has to be consistent. If you indented 4 spaces below if, you should indent the same amount under else. A good practice is to indent 4, so please always indent 4 spaces. Let's play one more time with the code. I'll add another statement outside the if-else block this time. So press the upper arrow to call a previously executed block, and press enter to add another line. I'm adding an unindented line here. Okay, and let's see what we get. So, because we didn't intend the last printing function, the function stayed outside of the if-else block, and that means that last printing function was dependent neither on if nor on else. Therefore, it will be always executed regardless of what happens inside the if-else block. So that was some good information on if-else and indentation. As far as data types are concerned, we have so far mentioned integers, strings, and floats. Now you're gonna learn two other data types that are lists and tuples. Both lists and tuples are often referred to as sequences because they are sequences of objects. Let's start with lists. Lists are the most important between the two. So let's start talking about lists. A list is a sequence of objects. And these objects can be numbers, strings, files, and many other data types. Let's create a list of integers. I'm gonna call my list file list and add 3 integers in the list. Let's quickly see what we got. So it's a list of integers. Now, each value of the list is called a list item. Lists are extensively used when automatically performing multiple actions, or iterating if you like. If you want to add more items to a list, you can use the append method. So append is a list method that adds a new element at the end of a list. And we use a dot notation to apply a method to an object. Now, lists are indexed, meaning that every element of a list, every item of a list, has a certain index starting from 0. So for our list, 2015 holds an index of 0, 2016 has an index of 1, and 2017 has an index of 2. Indexes are useful when we want to access certain items of a list. For instance, if we want the second element, we call the element with index 1. We write the list name and the index of the item we want to call inside square brackets, and we get the second item. And this item behaves just like an independent object. For example, in this case we have an integer, as you see. Now, you saw that we were able to modify a list, and we did that by adding an item at the end of our list. Sometimes you don't want your list to be modified for some reason, and in such cases we use tuples. To create a tuple, just use this syntax. So to declare lists we use square brackets. For tuples we use round brackets. It is rare to use tuples, but in case you want your series to be immutable, tuples are always there for you. So you just learned what lists and tuples are, and more data types in the next lecture. In this lecture, you will learn about sets and dictionaries. Remember, lists and tuples were referred to as sequences. Well, sets and dictionaries are referred to as collections, because they are unordered collections of items. Let's start explaining sets. A set is an unordered collection of unique items, and remember, unique items, not duplicate items allowed in a set. We can create a set using curly brackets, just like this. Let's say file set, and I'll store 3 integers in my set. A simple and practical use of sets now is when you have a list that has duplicate items and you want to remove those duplicate items from it. Let's say you have this list, file list, okay? We have 2 duplicate items. And to make a sequence of unique elements, you have to convert it to a set object. And we can convert a list to a set object using the set function. When you do that, duplicates will be removed automatically. So we are sort of updating our file list variable with a new value in this line of code. This new value will be a set that is generated by converting the list object to a set object. See now, printing the file list will reveal that duplicate items have been removed, and we now have a set object, not a list anymore. That is because we converted our list to a set. But don't believe me and check the type of the object always. So, if you want to retain your list data type, you can convert the set back to a list using the list function this time. So file list equals list, and we pass the set object to the list function. More data types now. Dictionaries. Let's try to explain them by making a comparison with lists. So in the case of lists, we were able to access items using their indexes. For dictionaries, we can access items using indexes declared explicitly by us. Here's a dictionary. I'll call my dictionary file dict, and we use curly brackets to define a dictionary, and then we write the index, a colon, and the corresponding item. So don't forget that each item has its own data type. So if you use quotes for an item that makes that particular item a string, and so on. The items in this case are 2015, 2017 and 2019, and they are referred to as values. So remember, values when we're talking about dictionaries. And the indexes are last year, this year and next year. They are referred to as keys. So what we're dealing here is an object constructed by pairs of keys and values. Now, in the case of lists and tuples, we were able to access items using the default indexes. In the case of dictionaries, you can access the dictionary values using their corresponding keys. And that will return the value attached to the year key. So far, you have learned some of the main data types available in Python. There are no hidden truths about integers and floats, but there may be a few things you need to know about sequences such as lists and tuples, and strings as well. So that's what I'll explain in this lecture. First, let's talk about indexing. Strings support indexing just like lists and tuples do. So let me generate a quick list using the list function and the range function as well. So I'll store my list in my file list variable, and I write the list function. So the list function generates a list object. And then to the list function I'll pass a range function, and then to the range function I'll pass a range of numbers starting from 2000 and ending at 2020 with a step of 2. And here is our list. Now I'll quickly teach you how to access certain parts of the list. So first we're gonna access a single item of the list, then we're going to access a certain slice of the list, then only the first 3 items, then all the items after the second item, and then only the last 2 items of the list. To understand and perform those actions, you should already know how the items of the list are indexed. So each item of the list is hiding a certain index underneath. Indexes start from 0 and increment by 1. So the first item has an index of 0, the second item has an index of 1, and so on. Now let's start by accessing an item of the list. Let's say I want the third item. Because the counting starts from 0, the index of the third item is 2. And the syntax is this. We write the variable name that contains our list, and then we write the index inside square brackets. And that's it. Python returns the third item of the list. The fourth element would need an index of 3, and so on. Now, sometimes you might need to access more than one element of the list. Let's say you want only that part of the list that starts at 2002 and ends at 2010, including 2010. To extract such a slice from a list, you need to know the index of the lower and the upper bound numbers of the slice that we want. In this case, they are index 1 and 5. The syntax is this. So the name of the list, square brackets, the index of the first number, a colon, and the index of the number after the upper bound number of the slice. So why the number after the upper bound number, you'd ask? Well, the answer is that slices and ranges are upper bound exclusive, meaning that the number identified by the last index is not included in the slice. So if you write 5 here, the slice will not include the item with index 5. Therefore, we write 6 to include the number with index 5. And we have our slice. Sometimes you might want to access only the first 3 elements of the list, for example. And you could do that using 0 as a lower bound index and 3 as the upper one. However, a quicker way to do that is to just use the last index without explicitly writing the number 0. So this is like saying, okay Python, give me everything before 3, including 3. And if you want a slice consisting of all the items after the second item of the list, you would need to write 2 and a colon inside the square brackets. So this is like, okay, Python, now give me everything after 2. And if you want the last 2 items of the list, you could count like 0, 1, 2, 3, 4, 5, 6, 7, 8, and tell Python to give you everything after 8, including 8. But hey, don't you find this a bit stupid? Counting from the start when you want the last 2 items? Sure, that's a bit silly, and that's why a second indexing convention exists along the first one that starts at 0 and incrementing by 1. So this second indexing I'm talking about starts at -1 at the upper bound of the list and decreases by 1. So -1 for the first item, starting from the upper bound, -2 for the second item, and so on. So if we want the last 2 items of the list, we don't need to count. We just can tell, hey Python, give me everything after -2, including -2. And if you want a slice that excludes the last 2 items, you could tell Python, hey, give me everything before -2, including -2. And that's it. Now, these were all list slicing operations. You could apply the exact same operations to strings as well. So if you have a string, let's say something, and I'm going to store it in a variable, the same indexing conventions apply to strings. So if you want the 4th character, you'd write the variable and then the index inside the square brackets, which is 3. I'll let you practice the rest of the slicing operations with strings on your own pace. Now tuples do not escape from these rules either. So we have this tuple, and I'm going to extract the last item only, and Python gives you everything after -1, including -1. I hope that was clear, and that's what I wanted to teach you about slicing lists, strings, and tuples. Iteration is crucial in programming. We do iterations to perform repeated actions in an automated way. Imagine you have 1000 different text files, and inside each text file there are 2000 different values, and you want to calculate the average of each of the 2000 values for each of the 1000 files. Well, to do that, you'd have to iterate through each file and through each value inside each file. The good news here is that Python is excellent in doing iterations with just a few lines of code. The great tool to perform iterations in Python is the for loop. We use the for loop every time we want to iterate through a list, through items of the list. So imagine we have stored the names of the files we want to iterate in our file list variable. Remember the file list variable? Now we want to just print out the file names on the screen one by one. To do that, we should use iteration. Here is the syntax to do iterating. So for item, in the file list, print out the item. And notice that we are using indentation here again. So what we're telling Python is, okay, for each item in the list, print out the item. And Python will do just that. It will go through each item and perform the action, which in this case is printing the item on the screen. So we had a list of 3 items, therefore there will be 3 iterations over the printing function. Sometimes you might need to generate a list automatically. Remember, we had to write the items of our list one by one. But imagine if you had to write a long list, let's say from 2015 to 3015. And I'll be very lazy to do that. But the good news is that there is almost always a way to automate your work in Python. In this case, we could iterate through such a big list of items using the range function. So again, for item in range, and then we write the first item of the sequence, the last item, and the step. So the step here is an incrementing step. And below comes the action we want to perform. And of course we can perform any action inside the loop and not just print. We can even do conditionals inside loops. let's do one again. So for each item in the range that starts at 2015 and ends at 2019, incrementing by 2, if the item is equal to 2025, print out the item. So we just told Python to go through each item of the range list and print only the item that is equal to 2025. We use indentation here again. We indented the if statement because it depends on the for loop, and we also indented the print function below if because the print function depends on the if statement. So the for loop here is conditioned by the fact that the item has to be equal to 2025 for the print function to be executed. So that was some basic but good information about iterations, but you'll have more about it in the next lectures. So let's start this lecture, and in this lecture you will learn how to work with files in Python. We'll start straight away by creating a text file in a certain directory in our computer. I have created an empty directory here in my Windows C drive where I'll be creating my text file from within Python. So I'll save my files in this directory. That directory is c/in. Now let's go straight ahead and create an empty text file in our empty directory. To do that, we use the Python open method. Remember that everything that is created outside of Python is reflected back to a Python object inside Python. That means that when creating a file in our computer through Python, we are automatically creating a Python file object. As always, we can store objects in variables. So here I'm storing the file object that I'll create in a variable, and I'll name my variable file. So file equals open, and then we write the path of our file. Now the path is the full directory, including the file name. And in my case it is c // and I'll call the file testing.txt, and we also want to specify here another parameter, and this parameter specifies the file opening mode. So if you just want to read a file, you'll use R, which stands for read. If you want to write content in that file from within Python, you'd want to use W, meaning write. I'm going to use write mode here for my file. And done. We have a new text file now in our system. But don't trust me, check to verify that. And here it is. Now, what we have done so far is created a file and opened it with Python. Opening the file with Python is essentially the same thing as opening it with other programs. Let's say Microsoft Word or Notepad, for instance. That means I cannot delete the file now because the file is already open in another program, which is Python in this case. If you want to delete the file, you have to close it first. And to do that, we use the close method. Now go ahead and delete it, and successful. Next, let's again create the file and write something on it. To write something in a file, we use the write method. I'm gonna write a string in my text file. Let's say such a nice file that I am. Now I'm gonna close the file and see what we have come up with. What we want to do next is open an existing file. And our existing file is testing.txt in this case. Again, we use the open method as we did earlier for creating a new file. And again, if we want to just read the content of the file, we use R. Otherwise, we use W. I'm gonna use R this time. Remember, with the read mode, we can only read, but with the write mode, we can both read and write. Now let's see what the file has inside from within Python. For that, we use a file method called read. So we used write before, now we use read. And I'll store the content in a variable called content. And we can see what we got in our content variable using the print function. And here we go. Let's close the file now. A few more things worth to mention are, if you open an existing file using the write method and you write something on it, the existing content of the file will be overwritten. Let's say I want to write this string, okay, new line here, and I want to close the file and see what we've got now. So the new string has overwritten the existing content. So you're thinking, how do we append content to an existing file? Well, that's simple. All you have to do is use the append method instead of the write method when you open a file, and A is the keyword for that. Now let's append a string. Notice here that the string is this goes to the next line. The \n is a keyword. If you don't use the \n, the line will be written in the same line with the existing text. The \n operator creates a new line break, allowing the new text to be written in the next line. Let's quickly check now what we got in our text file. First, we need to close the file. So we have a new text line in our file. And that was some good information that covered how to create a new file and open an existing one, and also how to write, read, and append content to a file. So, see you in the next lecture. Remember that once we opened a file, we had to close it later using the close method? Well, in this lecture, you're gonna learn a more solid way that closes a file for you once it has finished working with it. And this solid method is called with. So you will learn the with method in this lecture. Before we did this to open a file, we created a variable and then we used the open method to open a file, and then we used the write method to write something in that file, and later on we had to close that file. What you want to do instead is write a with statement. So to write a with statement, follow this syntax. Start with a with keyword, and then we write the open method, the file path, the writing method, and then the variable. The next line then is used to write the actions that we want to perform on the open file. In this case, we would like to write a line, for example. So don't forget to indent the second line. Again, we use indentation for the with method. And so how do we read this statement? Well, just like this. With the open testing.txt as file, we perform the actions in the next line. The benefit here is that the with method will close the file for us once the action below it have been completed. So it's a very compact method that is highly recommended. Great, I hope you followed the first 4 sections of the course, and I think now you are ready to do some more tangible things, rather than just looping through lists of nonsense numbers. And when I say doing tangible things, I mean to use your Python skills that you got in this course for writing Python programs that you will solve your problems and projects which are relevant to your fields of expertise. To write specialized programs, for example writing a program that analyzes some data, you will need the help of some sort of Python data analysis library, because Python does not have every possible functionality loaded by default. Therefore, in this lecture I'll show you how to look for libraries that suit your needs. But let me explain this through an example where I will perform some basic analysis on some data. Let's say I have these 3 text files here in one of my computer folders. Let me show what they have inside. So the first one has 1 column with a header and 3 values. The other one has also a header and 3 values. And the third one has basically the same thing. And what I want to do is calculate the average value for the values of each of the 3 text files. So I want to get 3 averages, 1 for each text file. The first place to look for a solution would be the list of Python standard libraries. And you can find the list of Python standard libraries by just making a search on Google. Python standard library, and the first result here is what you're looking for. Here we are at the official Python website, and this here is the list of libraries that were automatically installed when you installed Python. So you should have all these libraries installed with your Python version. For instance, the Signal library here should have already been installed in your computer, in my computer, and I can test that by importing the library in Python. So import and the name of the library, and if you don't get any error, that means the library is installed. But I'm not interested on the Signal library. I need a library for data analysis. So you can either scroll through the list to locate that, or you can search for the term data analysis. And it says that nothing is here. And that's normal, because these are all libraries for everyday programming, so it's probable that your specialized needs will not be covered by these standard libraries. Therefore, we go to another powerful list called PyPI. Just search on Google for the PyPI list and hit the first result. PyPI stands for Python Package Index. So PyPI is a repository of specialized Python libraries, or packages if you like, and here you can look for the library that suits your need. For instance, let's say you want a library for aerospace applications. To find it, I'll now scroll through all the 64,310 libraries until I find my aerospace library. Okay, that was a joke. I can just search for a keyword using Ctrl F on Windows and type in aerospace, and we got one result. So the name of the library is PyOpenFDM, and it also has a number. The number indicates the version of the library, and this library has a description here as well on the right. But if you want some more information about the library, you can click the text here, and that will bring you to the library webpage. Here you can find more information about the library. And the beautiful thing about all these Python libraries is that you can install any of them very easily. I already showed you how to install libraries in the first section of this course, but I would like to try it again very quickly with this library. So we use pip Python library to install other libraries. So just go to your command line and type pip or pip install and type in the name of the library without the numbers. That will install the latest version that resides in the PyPI repositories. Wait until the installation finishes and you're done. You can test if the library was correctly installed by importing it into Python. So just go to your IPython console and type import PyOpenFDM, and if you get no error, that means everything is fine. Now I don't know much about aerospace, so I'll just leave this here and look for my data analysis library so that I can solve my data analysis problem of calculating the average values of the data contained in the 3 text files. So I can search for the data analysis in the PyPI index, but because data analysis is quite a popular field, you will get a lot of results. So there are a lot of Python libraries that perform data analysis, and in that case a good idea is to ask, well, Google for some help. So we can just search for the term Python data analysis library. The first result probably documents the most popular data analysis library for Python, and it actually does. Pandas is the name of the library, and Pandas is a great library for data analysis. So I can just go ahead and install the library now. So pip install pandas. And it seems that I already have pandas installed in my computer, because if you install Python through the Anaconda package, you should already have the pandas library too, because pandas comes shipped with Anaconda. Great, that's how to find and get libraries installed in your computer. In the next lecture I'll write a program that calculates those average values. I highly recommend you to follow that lecture, as there you will see how variables, strings, numbers and loops come into play in the real world. So talk to you in the next lecture. Welcome! So once again, we have these 3 files here, and each of them has a column with some data values and a header called value. And I will now write a program that will access these three files, read their data in Python, and calculate three average values, one for each of the three columns. This can be probably done in different ways using different libraries, but one easy way to do this is to use the pandas library. So the pandas library is a data analysis library. And pandas is like an interface that creates a data frame object inside Python. This data frame object is like a structure that holds the data. So you can think of it as yet another Python data type. So as you work with other libraries, you will discover other complex data types. So first I'll go ahead and calculate the average value of the values inside the file 1.txt. First of all, I'll import the pandas library. And what we want to do first is generate a data frame object out of the first text file. So we will read the data of the first text file, and we will store those data in a data frame object. And we want to store the object in a variable. So remember, variables are like containers where we can store everything. And I'll call my variable df. Then I'll generate the data frame using the pandas read CSV method. So read CSV stands for read character separated values, and our text file is such a file. So it has that data structure. The file could also be a CSV file, .csv file, and things would work the same. So pandas.readCSV, and then we need to pass a parameter to the readCSV method. That parameter is the file path that we want to convert to a data frame. So we want to convert that file, and I'll pass my path here, which is C analysis, and the name of the file. And notice here that the path is a string data type, so Python recognizes strings objects, and when you pass the string to the readCSV method, the readCSV method parses the string, so it understands strings objects and locates the file in the computer through that given string. So let's hit enter here, and we have a data frame object generated. You can display the data frame if you want by just calling the variable that holds the data frame. So this is the data frame. So this is constructed of a header, which in this case is a value string. And the data frame also has an index column, which was assigned some default values, as you see here. And of course the data frame also has the values. So to calculate the mean value of all the data frame values, we just go ahead and apply the mean method to the data frame object. So df, the dot, and the method. And this is a mean value. So that was quite easy. Now we can calculate the average values of the other files the same way. So we can repeat the same actions. But here we have three files only, and we can do that. But imagine if we had lots and lots of files. And in such case, we would need to use a for loop. That's exactly what I'll do now. But in order to iterate through all the file paths, I first need to have a list of file path strings. And a smart way to get a list is to use a glob2 library. So first you should go ahead and install the library in your command line using pip install glob2. Good. Once the library has been installed, you don't have to restart anything, just go ahead and import the library in your console. And then you want to use a method of the library that generates a list of file paths, and that method is called glob. And I want to store the list of the file path strings inside a variable, of course. So let's say file list equals glob2.glob, so the glob method of the glob2 library. And here we need to pass the folder path where the files are located. So that is C analysis. And here we can play around by using an asterisk and a .txt after that. And that means we want all the files containing a .txt extension. And that's it. Execute and see what you got in the file list variable. So it's a list of all the txt file paths. Now we have a list of file paths, and we can iterate through that list and execute the same action for all the items of the list. Let's say for file in file list, and then we create a data frame object and call the readCSV method of the pandas library, and then pass the file path to that object. So that would be the file variable. Think of the file and the df variable as temporary variables, so they will have different values at each iteration. And next we can calculate the mean value of the current data frame of the iteration. And then we print out the value on the screen, and that's it. Execute, and we get 3 values here. So each of the values represents the average value for each text file. These values are actually a domestic pandas data type called series. So if you like to actually return a plain float Python data type, you could apply the float function to these numbers. So let's do just that. Let's modify our code and just press the upper arrow key to recall a previously executed statement. And what we want to do is add a line that converts the series data type to a float data type. And we can use the float function for that. So as soon as the m variable is created, we will grab that variable and pass it to the float function, which will convert it to a float data type. That's it. Execute, and here we have the 3 mean values. So I hope this was fun and full of useful information for you. Please feel free to post a discussion if there is anything you need to talk about, and see you in the next lecture. This is a short lecture about code introspection. And code introspection is the process of examining your functions and your features so that you know what they are and you know what they can do. And in Python there are a few functions and techniques you need to know about for retrieving such information. Let's take as an example the pandas library. So what we want to know is what the pandas library is about and what functionalities the library has available. To perform code introspection, you first need to have the library loaded in your console. So I'll go ahead and import the library. Now the first thing I want to examine from the pandas library is to check what the library is. For that, all I have to do is call the library and add the question mark after the name. And that returns some text which has some quick information about the library. And for more information, you can use the help function. So the help function is just a built-in Python function that takes as argument Python code, or like functions, classes, and methods and keywords, and returns some comprehensive information about them. So this is what we got from the help function. The first list here is important. These are the methods and objects that the pandas library is made of. So for instance, we see the readCSV method here, which we used earlier. We also have other information that is not crucial to know for now, and down below we also have the version of the pandas library that I have installed in my computer. This is where the library is located. So a library is like a collection of .py scripts that reside somewhere in your computer. Anyway, what is more important to know is again the list of functionalities that pandas have. You can retrieve a full list of features using the dir function. So dir, and pass the name of the object you want to introspect. So we want to check pandas, and here is what you have. So you can access any of these features using the dot notation. For instance, if you want to know what the pivot method is about, you can just go ahead and type in pandas.pivot and a question mark. And here is shown what the pivot method does, and it also describes the parameters you input to the method. Similarly, you can explore other methods and functions of the library. For instance, let's explore the dataframe object. So pandas.dataframe. So pandas dataframe object is like a prototype that holds the data you open in Python. Then this pandas dataframe object has yet other methods inside it. So what we're talking about here is a tree. The roots of this tree is a pandas library, and the tree has many branches. These branches may have other branches as well belonging to them. To see a list of branches of the dataframe branch, you again can use the dir method. So just like this, and these are all the functionalities you can apply to a dataframe object. So if you can recall it, For instance, you can export the data frame to an Excel file, HTML table, or etc. And again, if you need to know about these methods, go ahead and ask for information using the pandas.dataframe.toExcel, for example. And here is how to use the method and what parameters to pass. So that's what I wanted to show you in this lecture, and I hope that will help you along your way of using and mastering Python. Thank you. This is a short lecture about code introspection. And code introspection is the process of examining your functions and your features so that you know what they are and you know what they can do. And in Python there are a few functions and techniques you need to know about for retrieving such information. Let's take as an example the pandas library. So what we want to know is what the pandas library is about and what functionalities the library has available. To perform code introspection, you first need to have the library loaded in your console. So I'll go ahead and import the library. Now the first thing I want to examine from the pandas library is to check what the library is. For that, all I have to do is call the library and add the question mark after the name. And that returns some text which has some quick information about the library. And for more information, you can use the help function. So the help function is just a built-in Python function that takes as argument Python code or like functions, classes and methods and keywords and returns some comprehensive information about them. So this is what we got from the help function. The first list here is important. These are the methods and objects that the pandas library is made of. So for instance, we see the readCSV method here, which we used earlier. We also have other information that is not crucial to know for now. And down below we also have the version of the pandas library that I have installed in my computer. This is where the library is located. So a library is like a collection of .py scripts that reside somewhere in your computer. Anyway, what is more important to know is again the list of functionalities that pandas have. You can retrieve a full list of features using the dir function. So dir and pass the name of the object you want to introspect. So we want to check pandas, and here is what you have. So you can access any of these features using the dot notation. For instance, if you want to know what the pivot method is about, you can just go ahead and type in pandas.pivot and a question mark. And here is shown what the pivot method does. And it also describes the parameters you input to the method. Similarly, you can explore other methods and functions of the library. For instance, let's explore the dataframe object. So pandas.dataframe. So pandas dataframe object is like a prototype that holds the data you open in Python. Then this pandas dataframe object has yet other methods inside it. So what we're talking about here is a tree. The roots of this tree is a pandas library, and the tree has many branches. These branches may have other branches as well belonging to them. To see a list of branches of the dataframe branch, you again can use the dir method. So just like this, and these are all the functionalities you can apply to a dataframe object. So if you can recall it, for instance, you can export the dataframe to an Excel file, HTML table, or etc. And again, if you need to know about these methods, go ahead and ask for information using the pandas.dataframe.toExcel, for example. And here is how to use the method and what parameters to pass. So that's what I wanted to show you in this lecture, and I hope that will help you along your way of using and mastering Python. Thank you. Welcome to this very important lecture. And in this lecture you will learn how to make your script interact with the user. And the user is someone which you can give your .py program and they can execute it easily. This is done by integrating some code that makes possible the interaction with the user. So in this lecture I'll teach you how to receive user input for your program, and then the program can process this user input. So let's build a simple function here. Let's say miles to kilometers. And this function will get miles as input, and then it will convert these miles to kilometers. So miles is the parameter, and I know that 1 kilometer is equals to 1.60934 miles. So we multiply miles with that number, and then what we want to do with the output is print it out on the screen. So print the kilometer variable. Now let's call the function the way we are used to. So miles to kilometer, and then we pass an argument here. Good, and we get an output. However, a better way to call the function to generate an output would be to integrate an input function inside the script. So the input function is the function that implements the user interaction feature. So the idea is that the input function will ask the user to enter some input, and then it will get the input entered by the user and it will pass it as an argument to the function. So this is the idea. We want to store the input that will be entered by the user in a variable. So let's say m, which stands for miles, and that will be equal to the input function, and then the input function takes an argument, which is the message that you want to show to the user. So let's say please enter miles, and put a column there to give it a nice look, and that's it. And then what we want to do with this variable is pass it as an argument to the miles to kilometer function. So we just go ahead and call the function here and pass the m variable as an argument. So that's it. Let's go ahead and run this program now. Good. So the program is asking us to enter a value for the miles. I'll go ahead and type in 100 here and press enter, and we get an error. So why do we get an error? We're getting an error because Python is trying to multiply a string with a float number. So we enter 100, which is seemingly a number, but however the input function reads everything that you pass to it. It reads it as a string. So in this case it gets the number 100 and converts it to a string, and then it passes it to the function. So that's why we get an error. So we want to convert this given input from the user from a string to a float type. To do that, you just go ahead and type m equals float m. So what this does is it just gets the current value of m and converts it to a float data type. Now let's go ahead and run the program. Okay, we're asked to enter the miles. Let's say 100, and we get the output. So this is the idea of the user interaction. The program asks the user to enter some input, and then it gets the input and generates the output. Now we can polish the program even more. We can print out a kilometer string beside the value, just like this. So we add a comma and a string. So the print function will print out two values here. We execute the program again and enter some miles, and in this case you get a value and a label. One last thing I wanted to show to you is that you don't have to use Spider for executing a program. You can also execute a program using your command line. To do that, you should type the program which you want to execute the program with. Okay, so the program is Python, and then the Python program you want to execute is a .py script. So you enter the path of your .py script, okay, and press enter. And then as a user you just follow the instructions of the program and you finally get the output. So that's how you can interact with the user and get the user input and process it in your programs. Talk to you in the next lecture. So what you're looking at is a script you wrote in the previous exercise. And what you basically did there is that you asked the user to enter some input. So the user enter a longitude and a latitude value, and then you pass these values to the new point method. In this lecture I'll show you how to actually generate a KML file out of a CSV file. This is a more efficient way compared to the previous method So compared to the existing script you're looking at now, because using a CSV file you can actually pass many longitude and latitude values at the same time and get a KML file generated. So now you have to think, how do we get the data out of the CSV file? Well, I think I already told you that you can use the pandas library to do just that. Pandas is a powerful data analysis library and it can efficiently read CSV data and manipulate them. So I'm gonna delete these two lines here, okay, and import the pandas library. Great. Now the CSV file I'm talking about is this one here. So we have 2 columns and 4 rows, and I'm gonna keep my file here and my spider here. Good. So what we want to do now is create a data frame object, and we use a readCSV method for that, and here we pass in the path of the CSV file. So now we already have the data of the CSV file inside Python, and we're keeping them in the data frame object. What we want to do now is create a for loop which will iterate through all these 4 rows, and then it will execute the new point method 4 times. So the new point method will get the longitude and the latitude values for each of these rows. So the idea is that we have to start the loop above the new point method. So let's say for lon lat in. Okay, so so far I taught you how to iterate with 1 variable but not with 2 variables at the same time. So you used to iterate with 1 variable through a single list. Here, to iterate with 2 variables in 2 lists, we have to use the zip function. So the zip function allows you to iterate through 2 lists at the same time. And now our lists are, the first list is gonna be the longitude column. So to access such a list, we call the data frame, and then in the square brackets we write the column name of the data frame, which is longitude. And then we pass in the second list, which is latitude. Great, that's the idea. Now you want to indent this line here, and we don't have any name column in our CSV, so I'm gonna delete this. And then the arguments that we pass here to the course parameter have to reflect the names of the variables here. So I'm gonna pass lone and lat, and that's it. We have something here, it says invalid syntax. Of course we haven't added the colon here, and that's it. And we don't want to iterate through the save method, because the idea here is that we will create 4 points using the new point method, and then once these points have been added to the object, then we just save this object to a KML file. Great, let's run now. And we have an error. So the error has to do with the longitude string, and of course I've passed it through the wrong name, because the correct name is longitude. Great, let's execute again now, and let's check the KML file. So now we should expect 4 points in the KML file, and that's how it is. So in this lecture we leveraged the CSV data to create a KML file, and you may never have to create KML files in your life, but you may have to process CSV files, and the pandas library is a great library for that. And here you saw how to efficiently iterate through the rows of a CSV file. So I hope you learned something from this lecture, and see you in the next lecture. So what you're looking at is the script you wrote in the previous exercise. And what you basically did there is that you asked the user to enter some input. So the user enter a longitude and a latitude value, and then you pass these values to the new point method. In this lecture I'll show you how to actually generate a KML file out of a CSV file. This is a more efficient way compared to the previous method, so compared to the existing script you're looking at now, because using a CSV file you can actually pass many longitude and latitude values at the same time and get a KML file generated. So now you have to think, how do we get the data out of the CSV file? Well, I think I already told you that you can use the pandas library to do just that. Pandas is a powerful data analysis library and it can efficiently read CSV data and manipulate them. So I'm gonna delete these two lines here, okay, and import the pandas library. Great. Now the CSV file I'm talking about is this one here. So we have 2 columns and 4 rows, and I'm gonna keep my file here and my spider here. Good. So what we want to do now is create a data frame object, and we use a CSV method for that, and here we pass in the path of the CSV file. So now we already have the data of the CSV file inside Python, and we're keeping them in the data frame object. What we want to do now is create a for loop which will iterate through all these 4 rows, and then it will execute the new point method 4 times. So the new point method will get the longitude and the latitude values for each of these rows. So the idea is that we have to start the loop above the new point method. So let's say for lon lat in. Okay, so so far I taught you how to iterate with 1 variable but not with 2 variables at the same time. So you used to iterate with 1 variable through a single list. Here, to iterate with 2 variables in 2 lists, we have to use the zip function. So the zip function allows you to iterate through 2 lists at the same time. And now our lists are, the first list is gonna be the longitude column. So to access such a list, we call the data frame, and then in the square brackets we write the column name of the data frame, which is longitude. And then we pass in the second list, which is latitude. Great, that's the idea. Now you want to indent this line here. And we don't have any name column in our CSV, so I'm gonna delete this. And then the arguments that we pass here to the course parameter have to reflect the names of the variables here. So I'm gonna pass lone and lat. And that's it. We have something here. It says invalid syntax. Of course, we haven't added the colon here. And that's it. And we don't want to iterate through the save method because the idea here is that we will create 4 points using the new point method. And then once these points have been added to the object, then we just save this object to a KML file. Great. Let's run now. And we have an error. So the error has to do with the longitude string. And of course I've passed it through the wrong name, because the correct name is longitude. Great, let's execute again now. And let's check the KML file. So now we should expect 4 points in the KML file. And that's how it is. So in this lecture we leveraged the CSV data to create a KML file. And you may never have to create KML files in your life, but you may have to process CSV files, and the pandas library is a great library for that. And here you saw how to efficiently iterate through the rows of a CSV file. So I hope you learned something from this lecture, and see you in the next lecture. So here I have the script that we wrote in one of our previous lectures. So what the script does is that it reads a CSV file using pandas and stores that CSV file as a data frame in Python. And then we loop through the columns of this data frame and we execute the new point method for each row of the columns. And then we save the generated KML file, which will contain the points given the coordinates that were located in the CSV file. In this lecture, I'll show you how to make a graphical interface. And the graphical interface you'll make is this simple window here, which has 2 buttons. And then we will make these buttons functional in the sense that when you click them, they'll do something, as you might guess now. So let's go ahead and do that. And so to make graphical interfaces in Python, there are quite a few libraries which you can use. A very simple library, however, which is very preferable by programmers and by me eventually, is Tkinter. Tkinter should be already installed with your Python, and so you can just go ahead and import it. Now, the very first thing that you want to do after having imported the Tkinter library is to create an empty window. And the way to create that is that you assign the window to a variable, let's say root, and that will be equal to Tkinter library.tk. So tk is the method that creates a window. And then you always apply the main loop method to the window object, just like this. What main loop basically does is that it keeps the window on the screen until the user presses the close button. So let's execute this now, and we get this very simple window which has nothing in it. Now you want to add things into the window, and these things are called widgets in Python. So you want to add some buttons. These buttons are called widgets. You want to add some text in the window. This text is called a label, and it's still a widget. So I'm going to close this now. And the first thing, however, is to add the title property. And to add a title, you just refer to the root object and then to the title method, and then you just pass the title inside the quotes. Let's call it KML generator. Execute to check, and we don't have the title that we assigned, and that's because you assigned the title outside of the main loop. So this is another reason why main loop exists. So if you have multiple windows in a script that you want to create, you put all the code of these windows between the tk method here and the main loop method. So now we execute and we have the title. Good. Now let's go ahead and add a label to the window. And what you want to do is store the label in a variable, which I'll call a label. And then you refer to the Tkinter library and access the label method. Now what the label takes as arguments is the name of the window object, which is root, and then you need to pass the text argument, which is a string, and here you pass what you want to write. So let's say this program generates a KML file. Good. Now you have created a label object, but you haven't packed it. So what you do in Python, you create a widget and then you pack it using the pack method. That's it. Let's execute. And so we have some text here. Great. Now it's time to create a button. So to create a button, you use the button method. So just to remind you, what we're trying to do here is create a graphical interface with a browse button and a KML generator button. And when we press the browse button, we want our program to prompt us to select the CSV file that we want to convert to a KML file. So the browse button will ask us for the file input. And then when we press the KML generator button, we will trigger Python to actually execute the conversion between the CSV file and the KML. So basically when we press the KML generator button, Python will execute these lines of code. However, for now we're just creating the graphics. So let me call the button browse button, and that will be equal to the tkinter.button. And then again we pass the window object, which is root, and then the text parameter, which will be browse. Great. And don't forget to pack the button and execute to see what happened. So we have a window with a button, which doesn't do anything now, because we haven't assigned any command to the button. So in order for the button to do something, you have to add another parameter here called command. And that will be equal to some function that you have defined in the script. However, I'll leave this empty for now, and I'm gonna go ahead and create another button. Let's say KML button. I'll just copy this and I'll call this KML button. And I want to change the text, of course. Let's say generate KML and see what we got. So we got two buttons. So that's what I want to show you in this lecture, and in the next lecture we will see these buttons in action. See you later. Good. What you're seeing here is the script that we created in the last lecture. And what this creates is a window with a browse button and a generate KML button, which for now do nothing. But the thing here is that every time we execute the script here, a window is created, but also we are creating a point.kml file because these lines are being executed too. What we want instead is to actually execute these lines when we press the generate KML button. So the first thing we have to do here is to actually wrap these lines inside a function. So let's say def camel function, and here we have to pass two parameters. We need an infile parameter and an outFile parameter. And we can put some default values to these two parameters. So the first will be the input file, and the second is the output file. Great. And of course, this parameter needs to reflect the input for the read CSV file and for the save method. We have an error here, invalid syntax. Yes, we haven't added the colon. And now to indent all these lines easily, you just go ahead to edit and indent. So we have a function. Now if I delete this file and execute the script, we are just calling the window. So the file is not generated. So instead we want to call this function when the generate KML button is pressed. For that we need to add a command parameter, and that will be equal to the name of the function that we want to execute. That's it. Now execute the script and say generate KML, and we have the points KML file generated. And here are the points. Good. Let's close this now. So that's how to add an action to the generate KML button. What we also want to do is append a function to the browse button as well, so that when the browse button is pressed, the user will be prompted with a dialog window asking the user to specify the CSV file that they want to process. To create such a dialog window, you have to import the askOpenFileName method from Tkinter again. So from tkinter.fileDialog import askOpenFileName. So the file name method is a part of the file dialog class of the Tkinter library. But before we use the askOpenFileName method, I would like you to see what this actually does. So I'm going to go ahead and run this line in the IPython console. Great. And then I'll create a variable and assign to the variable the askOpenFileName. Execute. And so we have the dialog window. Now if we select a file here and say open, seemingly nothing happened, but if we print out the file path variable, we will get the path of the file that we selected. So what the askOpenFileName is doing is that it's generating a string out of the file that we are specifying in the dialog window. So now we have to make use of that and pass that string to our KML function. So let's go ahead and do just that. And what we want to do now is to actually append the askOpenFileName method to the browse button that we have created. And for that we again have to create a function. So let's say def browse, and here we say infile equals askOpenFileName. And then we want that the browse button returns the file path string. Now we assign the browse function to the command parameter. And let's execute the script now to see what's going on, but I'll delete the KML file first and execute. And so we have two buttons, so let's test the browse button. Good, looks good. And let me specify the file I want to convert to KML. Great, and then press generate button. And we get the points.kml file. Now everything looks beautiful, but it's actually not as beautiful as it looks like. It is true that when we press the generate KML button, the KML function is triggered. However, if you look closely here, you'll see that the KML function is getting the file input from this string. But this is not what we wanted. What we wanted was that the KML function gets the string out of the browse function. So the browse function is the function that generates the file path string. So what we want to change here is that we want to call the browse function inside the KML function. Now this way the returned infile value will be passed to the infile parameter here. Good. Let's execute this now. So we got an open dialog window, but we didn't want it to get the dialog window immediately. We wanted to get it after we press the browse button. So why is this happening? The reason is that when Python executes a script, it starts from the first line and all the lines one by one down to the bottom. And when it goes to the functions, it reads the definition of the functions, and then it goes to the KML function, and what it does here is that it executes the browse function. So before triggering the action by pressing the browse button, Python is executing the browse function before we press the browse button. So we need a way that allows us to grab the in-file path string from the browse function, but doesn't execute the browse function. So the thing that does the trick here is the global variables. So as I already told you in the lecture about the global variables, we use a global variable when we don't want to execute the function, so we just want to fetch some information inside of that function. In such a case, we don't need the return infile here, but we just want to make the infile variable global variable. And of course, we have to remove the argument here. So what happens now is that when the script is executed, so it reads the definition of the browse function, it reads the definition of the KML function, and it doesn't call any function when it reads this definition. But before we had the browse function being called in the KML function. So let's test this now, and I'll delete the points.kml file, run, and we get the window very nicely. Browse, I'll go to my computer, which for some reason I have renamed to 7, and go to out, coordinates, click generate, and we have the points KML file generated. Here is our African savanna. Great, so this is how you create graphical interfaces and assign functions to them so that they actually do something. I'll see you in the next lecture then. Good. What you're seeing here is the script that we created in the last lecture. And what this creates is a window with a browse button and a generate KML button, which for now do nothing. But the thing here is that every time we execute the script here, a window is created, but also we are creating a point.kml file because these lines are being executed too. What we want instead is to actually execute these lines when we press the generate KML button. So the first thing we have to do here is to actually wrap these lines inside a function. So let's say def KML function, and here we have to pass two parameters. We need an infile parameter and an outFile parameter. And we can put some default values to these two parameters. So the first will be the input file, and the second is the output file. Great. And of course, this parameter needs to reflect the input for the read.csv file and for the save method. We have an error here, invalid syntax. Yes, we haven't added the colon. And now to indent all these lines easily, you just go ahead to edit and indent. So we have a function. Now if I delete this file and execute the script, we are just calling the window, so the file is not generated. So instead we want to call this function when the generate KML button is pressed. For that we need to add a command parameter, and that will be equal to the name of the function that we want to execute. That's it. Now execute the script and say generate KML, and we have the points KML file generated. And here are the points. Good. Let's close this now. So that's how to add an action to the generate KML button. What we also want to do is append a function to the browse button as well, so that when the browse button is pressed, the user will be prompted with a dialog window asking the user to specify the CSV file that they want to process. To create such a dialog window, you have to import the askOpenFileName method from tkinter again. So from tkinter.fileDialog import askOpenFileName. So the file name method is a part of the file dialog class of the tkinter library. But before we use the askOpenFileName method, I would like you to see what this actually does. So I'm going to go ahead and run this line in the IPython console. Great. And then I'll create a variable and assign to the variable the askOpenFileName. Execute. And so we have the dialog window. Now if we select a file here and say open, seemingly nothing happened, but if we print out the file path variable, we will get the path of the file that we selected. So what the ask open file name is doing is that it's generating a string out of the file that we are specifying in the dialog window. So now we have to make use of that and pass that string to our KML function. So let's go ahead and do just that. And what we want to do now is to actually append the ask open file name method to the browse button that we have created. And for that we again have to create a function. So let's say def browse, and here we say infile equals ask open file name. And then we want that the browse button returns the file path string. Now we assign the browse function to the command parameter. And let's execute the script now to see what's going on, but I'll delete the KML file first and execute. And so we have two buttons, so let's test the browse button. Good, looks good. And let me specify the file I want to convert to KML. Great, and then press generate button. And we get the points.kml file. Now everything looks beautiful, but it's actually not as beautiful as it looks like. It is true that when we press the generate KML button, the KML function is triggered. However, if you look closely here, you'll see that the KML function is getting the file input from this string. But this is not what we wanted. What we wanted was that the KML function gets the string out of the browse function. So the browse function is the function that generates the file path string. So what we want to change here is that we want to call the browse function inside the KML function. Now this way the returned infile value will be passed to the infile parameter here. Good. Let's execute this now. So we got an open dialog window, but we didn't want it to get the dialog window immediately. We wanted to get it after we press the browse button. So why is this happening? The reason is that when Python executes a script, it starts from the first line and all the lines one by one down to the bottom. And when it goes to the functions, it reads the definition of the functions, and then it goes to the KML function, and what it does here is that it executes the browse function. So before we triggering the action by pressing the browse button, Python is executing the browse function before we press the browse button. So we need a way that allows us to grab the infile path string from the browse function, but doesn't execute the browse function. So the thing that does the trick here is the global variables. So as I already told you in the lecture about the global variables, we use a global variable when we don't want to execute the function, so we just want to fetch some information inside of that function. In such a case, we don't need the return infile here, but we just want to make the infile variable global variable. And of course, we have to remove the argument here. So what happens now is that when the script is executed, so it reads the definition of the browse function, it reads the definition of the KML function, and it doesn't call any function when it reads this definition. But before we had the browse function being called in the KML function. So let's test this now, and I'll delete the points.kml file, run, and we get the window very nicely. Browse. I'll go to my computer, which for some reason I have renamed to 7, and go to out, coordinates, click generate, and we have the points.kml file generated. Here is our African savanna. Great, so this is how you create graphical interfaces and assign functions to them so that they